Dear students, in our last classes we discussed various methods of computing index numbers. So mainly we divide them into two types, that is simple or unweighted index numbers, and second one is weighted index numbers. So in simple, again we categorize into two. One is simple aggregative, that is where we take a total of all the given prices for two different years, that is base year and current year. Then we calculate index number. Second one is average of price relative, where we calculate price relative for each individual items, and then we make a total of it and we calculate average. And when it comes to the average of price relative, we calculate two different types again, that is one is arithmetic mean and geometric mean. So here we have a problem. Calculate simple arithmetic mean price index number for the following data. So here simple arithmetic mean is given, where 5 different items or commodities are given and their prices in the year 2010 and 2012 are given. So here prices in the year 2010 and 12, with help of which we have to calculate arithmetic mean price index number. To calculate that, first we need to write the formula. The formula to calculate simple arithmetic mean index number, which is indicated by P01, is equal to summation P divided by N, where P is equal to P1 divided by P0 into 100, that is price relative, and where N is equal to number of items or commodities or observation given, that is 5 here. N is equal to 5 here. Now let us calculate P here. First one, P for the year 2000, for the item rice here 2012, P1. Let us make changes here. Base year price 2010 is considered as a base year as it is earlier, and 2012, which is recent one, which is considered as a current year. Let me make changes that 2010 as a base year, which is denoted by P0, and current year price indicated by P1. So here P1 is 12, P0 is 10. So 12 divided by 10 into 100, that is 120. So in the same way, let me write them here in a table. P. So P is equal to P1 divided by P0 into 100. So 12 divided by 10 into 100 is 120. Next 10 divided by 8 into 100, which is 125. Then 20 divided by 16 into 100, 125. 6 divided by 8 into 100, where price has reduced here. So which is 75. And last 4 divided by 5. 4 divided by 5 into 100 is 80. Now let us make the total for this column. We need a total of P column here. So 5 plus 5 plus 5, 15 plus 1, 8 plus 1, 9, 9 plus 6, 7, 16, 16 plus 2, 18, 20, 22, here 2, 3, 4, 5, 525. So P01 is equal to 525 divided by N is 5. So 525 divided by 5, we get here 105. So price year, price index number, simple arithmetic mean price index number for the year 2012 with compared to base year 2010 is 105. That means here it indicates price level has increased by 5% here. Price level increased by 5%, and with the base year current year index number is 105. Here we have a problem where arithmetic mean but weights are given here. Compute weighted arithmetic mean price index number from the following data, and here along with the prices for two different periods, weights are given. And remember here, weights may be anything. what they have given, that we should remember here. So here weights are given in the percentages. In percentages means the total of weights will be always equal to 100. So weights total is here 100. Let us check. 10 plus 25, 35, 35 plus 15, 50, 50 plus 30, 80, 80 plus 20, 100. So when weights are given in percentages, the total of weight column will be equal to 100. And weight may be given in any manner again. If it is not mentioned here in percentage, we may get a serial number 1, 2, 3, 4, or maybe reverse number 5, 4, 3, 2, 1, or maybe any other number. Depending on the importance, the weightage will be given here. And here simple arithmetic mean, we calculated just price relative and total of price relative divided by number of observation. Here weighted weighted arithmetic mean they have asked, means price relative we have to find, then we have to multiply that price relative with weights here. So what is the formula here? The formula is P01. So that is weighted arithmetic mean price index number. P01 is equal to summation WP divided by summation W. So what is P here? P is equal to P1 divided by P0 into 100, and W is nothing but weights which are given in percentages here. So let us find P here, price relative. First here P, we need to calculate two more columns here. So one is the price relative column P, and second one is weights into price relative WP. So first here 2018 and 2020 are given. So 2018 is the earlier year, that is base year here, and 2020 is a recent one, so which will be considered as a current year. So let me mark them with the notation, that is base year as a P0 and current year as a P1. So now P1 divided by P0 into 100. So P is equal to P1 divided by P0 into 100. So 40 divided by 32 into 100, we get 125. Then 32 divided by 25 into 100, we get 128. Then 20 divided by 25 into 100, we get 80. Then 80 divided by 50 into 100, that is 160. And finally 100 divided by 110 into 100, we get 90.909090. So we take 90.91. So in next step, find weights into P column. So 10 into 125, 1250. Then 25 into 128. So 25 into 128 is 3200. Then 15 into 80. So 15 into 80 is 1200. And 30 into 160. 30 into 160, 4800. And last 20 into 90.91. So 20 into 90.91, we get 1880.2. Now make the total of these columns here. We need WP column total and weight column total. So weight column total here is 100 as it is given in percentages. Let us make total of WP column total. So here WP column total, we get 12,268.2. 12,268.2. So put that in the formula here. So P01 is equal to summation WP, that is 12,268.2 divided by summation W, that is 100 here divided by 100. So P01, you get 12,268.2 divided by 100, we get 122.682. So, weighted arithmetic mean price index number for the given data here is 122.68. So, compared to base year 2018, the price index number for the year 2020 is 122.68. That means here in the current year price level has increased by 22.68%. Okay, and what about simple arithmetic mean? Do we get the same figure, same answer for simple arithmetic mean? No. So when we calculate simple arithmetic mean, which will be less than weighted arithmetic mean. Let us check. Just checking here. So P column we have here. So total of P column we get 583.91. So simple arithmetic mean. Simple arithmetic mean price index number formula is P01 is equal to summation P divided by N. So N is 5 items are given. So N is 5. So summation P is 583.91 divided by 5. So we get here 583.91 divided by 5. We get 116.6. 116.6. And here weighted arithmetic mean is 122.68. So always we get both the different answer here depending on the weights. Here weighted arithmetic mean varies compared to simple arithmetic mean. And let us calculate geometric mean index number for another problem here. Here we have a problem to calculate geometric mean. So compute weighted geometric mean price index for the following prices of 2012 and 15. So here prices of 2012 and 15 are given for 5 different items and weights. So as I said, weight may be anything here. So weights they have given reverse serial number 54321. So in percentages they are not given. Even we may get different figures there. They may give 20, 30, 50, 48, 69, various numbers also. So here we have numbers. Okay. So now what is the formula to calculate weighted geometric mean price index number? So weighted geometric mean price index number, which is again indicated by P01 is equal to anti-log of summation W into log P divided by summation W. So where P already we know, P is nothing but price relative P1 divided by P0 into 100. So that means we have to calculate next column is P, that is P1 divided by P0 into 100. So then we need to calculate log P. So as we need log P here, which should be multiplied into weights. So log P into weights. So that means we need one more column here, W into log P. So here, now let us find P for all the values here. So first 2015 is the current year, we mark it as a P1, and 2012 is a base year, let us mark it as a P0. So P0, P1, both columns we have P1 divided by P0. So 110 divided by 100 into 100 is 110. Then 60 divided by 40 into 100, 150. 25 divided by 20 into 100, we get 125. Then 18 divided by 12 into 100. So 18 divided by 12 into 100 is 150, and 2 divided by 1 into 100, 200. So price relatives are completed. Now we have to find log values for the prices here. So log P, first 110. For 110 log value. So here I think you all know how to find log values. So first we have to write the base. So base based on the number of digits here. So 3-digit number is there. So 2.2.2.2.2.2. And the next Mantissa we find in the log table. So if you have a scientific calculator, we can find them directly. So here for 110, log value is 2.0414. Then for 150, 2.1761. For 125 is 2.0969. And for 150 it is 2.1761. And for 200 it is 2.3010. And now we need to find the next column, that is W into log P. So W column is here, base column W, and P log P is here. So W into log P, we get 5 into 2.0414, we get 10.207 plus next 4 into 2.1761, that is 8.7044. Then 3 into 2.0969, we get 6.2907. Then 2 into 2.1761, we get 4.3522. And last one, 1 into 2.3010, we get 2.3010, etc. Now make the total of W into log P column, that comes to 31.8553. So now here put that in the formula. So P01 is equal to, and in log of summation W log P, that is 31.858853 divided by summation W. Summation W column total is comes to 15. So 31.858853 divided by 50. We get anti-log of, so 31.8553 divided by 15 is 2.1237. So this is not the final answer. So when we find anti-log for this 2.1237, that is the final answer. So anti-log of 2.1237 is 132.9536. So approximately is equal to 132.95. So weighted geometric mean for the prices in the year 2012 and 15 is 132.95, where price level increased by 32.95%. So as I said here earlier, geometric mean index number is always less than arithmetic mean. Let us find that, but before that I would like to calculate one more calculation here, that is simple geometric mean. So what is the formula to find simple geometric mean price index number? So here simple geometric mean price index number, that is nothing but P01 is equal to summation log P divided by N. Just find the log values for P and make the total of log P column divided by N. N is number of items given here, that is 5. So log P, what is the log P here? Log P here is 10.7915. So we get, that is anti-log of summation log P we have to find. So P01 is equal to anti-log of 10.7915 divided by 5. So we get anti-log of 10.7915 divided by 5, we get 2.1583, and anti-log value of 2.1583 is 143.9793. 143.9793. So here simple geometric mean tells that price level increased by 43.97%. Whereas the weighted geometric mean is telling price level increased by 32.95%. And let us cross check whether arithmetic mean is showing more or less. So already we have a data here. P is there, weight column also is there. Let us find the log P into W column, that is WP. So 110 into 5, we get 550. 150 into 4, 600. 125 into 3, 375. 150 into 2, 300. And 200 into 1 is 200. Then the total of WP column is 2025. And already we know the formula to find the weighted arithmetic mean price index number, that is P01 is equal to summation WP divided by summation W. That comes to 2025 divided by 15 is equal to. So 2025 divided by 15, we get answer 135. So weighted geometric mean is showing 132.95, whereas weighted arithmetic mean is showing 135, which is greater than again weight geometric mean. So 135 is the weighted arithmetic mean price index. What about simple arithmetic mean here? So simple arithmetic mean P01 is equal to summation P divided by N. So P column total is 735. So 735 divided by 5 items. So 735 divided by 5, we get 147. So simple geometric mean and simple arithmetic mean if you compare. So simple geometric mean is showing 143.97, whereas simple arithmetic mean is showing 147. So always as a set, geometric mean average will be less than arithmetic mean average here. So in both weighted arithmetic mean, weighted geometric mean we compare, and weighted simple arithmetic mean and simple geometric mean. In both the cases, arithmetic mean is greater than geometric mean. So in exam, all the things will not be asked. Either weighted arithmetic mean or weighted geometric mean may be asked with the 5 values, or maybe simple arithmetic mean or simple geometric mean. Any one of these two will be asked with more than 5 items here for 2 different years. So this is how we calculate arithmetic mean for price relative and as well as geometric mean for price relative, simple or even weighted. So when weights are given, weighted. If weights are not given, simple or unweighted averages of price relative. So in our next classes, we learn how to calculate aggregative weighted index number. So we have completed here simple aggregative price index number, simple arithmetic mean of price relative, and simple geometric mean of price relative, and weighted arithmetic mean and weighted geometric mean of price relative we calculated. And now the part left is weighted aggregative. So weighted aggregative, here 5 different persons have given their own formula. More than 5 persons have given, but mainly we study here 5 plus 1, 6 formulas given by 6 different mathematicians. So first one comes to Laspere, and Pasteur second one, third one Marshall Edgeworth, fourth one Dorbish Boles, and fifth mathematician is Fisher. So these 5 persons, they have used weights one of the given data here, that is for price index number, weights are quantities, whereas for quantity index number, weights are prices. Where here what weight given are, they are separate weights. They may be expenditure pattern, or maybe proportionate or percentage of the expenditure, or maybe anything, so which is not linked or here to the quantity or anything here, it is separate. Whereas weighted aggregative method, for price index number, quantities are weights, and quantity index number, price are weights. So let us find which author has, which mathematician has taken which quantities as a weights here, base year quantities or current year quantities, or both, or what. So let us discuss them in our next class.